For lesson 9, congruence in terms of rigid motions, we're going to further look at how our rigid motions, rotations, reflections, and translations result in congruent triangles, shapes, whatever we're talking about. In the diagram below, triangle A prime, B prime, C prime is a transformation of triangle ABC. And A double prime, B double prime, C double prime is a transformation of triangle A prime, B prime, C prime. The composite transformation, so remember, composite just means two or more transformations from ABC to our double prime triangle is an example of, well, as we go from ABC to A prime, B prime, C prime, that is clearly a translation. All right, that triangle was just slid over to the down and to the right. And then as we go from the second piece, the prime to the double prime, it is clearly a flip. So it is a reflection. And yes, the order is important. So we are going to end up with choice D, a translation followed by a reflection. For number 2, describe a sequence of rigid motions that would map pentagon ABCDE onto pentagon and then our double prime. So we're not on a graph here, so we have to get very specific as to how we are rotating, reflecting, translating. The first thing I notice is that we are dealing with different orientations. So once we do that, then I know we have to have a reflection in here of some sort. And that's how I'm going to start. I'm going to start by reflecting. So reflection over, and we're going to do it over line segment AE. So when we do that, we end up here with our pentagon shape. And if we do it over line segment AE, then we end up with A prime and E prime ending up in the exact same spots and only a few points actually moving. So we're going to start with a reflection over AE, and then we're going to need to slide it because now everything's facing the same direction, but we have to translate it. So we're going to translate. We want to talk about the vector that we're going to follow. So we're going to translate along vector and just pick one of them that makes sense. And to me, I like the looks of, because it's out of the way, I like the look of vector C. Oops, gotta get back to my pen function here. Vector C prime to C double prime. So that clearly shows, and if we slide them all along that same angle, because if you remember, all of our vectors are parallel to each other, and they're the same distance. So if we went B prime to B double prime, A prime to A double prime, and so on, they would all be the same. I just picked C prime to C double prime because it's out of the way, it doesn't overlap, it's very straightforward. So that to me is the easiest way to do this, a reflection over AE, and then a translation along vector C prime, C double prime. Now if we want to explain why pentagon ABCDE is congruent to our double prime, well, we're going to go with our statement that we've been doing, or we've been using throughout the entire unit, which is reflections and translations are rigid motions which preserve size and shape. So we need to state the rigid motions that we use, in this case, reflections and translations. We need to mention the word rigid motions, and we need to say what a rigid motion does, which in this case is preserve size and shape. And I want to go back up to the top, just in case somebody wanted to do this in our composition notation. It would look like that. It would be a reflection over AE, line segment AE, composed with a translation, C prime to C double prime vector, and then it's what we did it to, and we did it to, the original shape was A, B, C, D, E. So there's our problems number 2 and 3. In the figure below, triangle on the left has been mapped onto the one on the right by rotation of 80 degrees about vertex C. identify all 6 pairs of corresponding parts. So there's our angles and sides. So I'm going to start with the easy one, which is C, because angle C does not change. Since that is the center of rotation, that's going to remain equal the entire time. We are going to end up with angle angle A is going to end up on angle E, and angle B will end up on angle F, which means that our corresponding sides, well, if we had angle A and B, that's going to correspond to E and F. AC would be C and E, okay, or EC, same thing. And then BC is going to end up being CF. So there are all of the corresponding sides and angles for this shape. And if we wanted to put this into function notation, we would have a rotation centered at C of 80 degrees to triangle A, B, C. So that's what this looks like in function notation. So capital R for rotation, centered at vertex C of 80 degrees. And the only reason we knew it was 80 degrees was because they told us that. And what did we do it to? We did it to triangle A, B, C. Then our last piece, quadrilateral MATH and its image double prime M and so forth, are graphed on the set of axes below. Describe a sequence of transformations that would map the quadrilateral MATH onto the double prime. Now again, be careful. Make sure you're starting on the right shape. So the easiest way for me to see this is I'm going to look first and notice I've got clockwise orientation and I have clockwise orientation again. So because the orientations are the same, I'm thinking I'm probably not going to use a reflection of some sort. My first thought is to take this original shape and to rotate it around the origin or around point H, either one, 180 degrees. And when I do that, I end up with obviously point H staying the same for H prime. I end up with T being 1, 2, 3, 4. So I end up with 1, 2, 3. So I end up with T prime being there. I end up with A prime being 1, 2, 3, 4, 1, 2, 3, 4. So -4, -4. So there's A prime. And then M prime would be 1, 2, 1, 2, 3, 4. So -2, -4. So I end up with there is M prime. So if we look at what I've got there, this is our first rotated shape. And you can see that we are almost on top. But every point needs to go left one and up one. So we need to do a translation, left one and up one. So we can either write this in words, which would be a rotation 180 degrees around H, or you could say around the origin, since those happen to be the same exact spot. Then a translation left one and up one. So that's how you would do it in words. If you wanted to put this into composition notation like I had started to before, you would have done a translation -1, 1, composed with a rotation centered at H of 180 degrees to MATH. So again, remember, you work from right to left, so that rotation's got to go first. You could have translated it -1, 1 to get to H double prime first, so that the H's were on top of each other. But then you would have no option of the origin. You would have had to center it at H. So if you take what I wrote and you flip the order in this case, it will work. I just looked at this one as the easiest way to do it.